Questions 21 through 25 on the 2008 Grade 10 AMC 10A. A cube with side length 1 is sliced by a plane that passes through two diagonally opposite vertices A and C, and the midpoints B and D of two opposite edges not containing A or C as shown. What is the area of quadrilateral ABCD? Well, ABCD, that is our quadrilateral, and we have to somehow figure out the area. Okay. First thing is that we will need to figure out the lengths of each side, and let's do that. So here we go. The first is, of course, A to D, and that's pretty straightforward. We can use Pythagoras. AD is going to be, in terms of Pythagorean theorem, AD squared will be, this is 1, this is a half because D is the midpoint. So 1 squared plus 1/2 squared, and this is 5 over 4. So AD is equal to root 5 over 2. And in a very similar way, we can figure out all the others. A to B, for example, and that is going to be AB squared is equal to, the distance from here to here is 1 because that's the side of the cube. The distance from here to here is a half since B is the midpoint. So again, we get the exact same result, that AB is equal to root 5 over 2. And if you continue and do this for BC and BD, you'll get similar answers. And therefore, this is actually not really that difficult because it is a rhombus. It has the same side length for all four sides. And that side length is root 5 over 2. Like that. So how do you figure out the area of a rhombus? Well, one way is to figure out the diagonals. And diagonals multiplied by each other divided by 2, like that. So if you label this is A, B, C, D, and our diagonals on this diagram will be AC and BD. So if we can figure out the distance from AC and then the distance from B to D, we'll be able to solve this. So first, let's just do, either one is fine, BD. Looking at the diagram, that's this distance right there. And that can be easily solved considering the fact that it's essentially like this. A Pythagorean relationship like that, where this is 1, and that's BD. So BD squared is 1 squared plus 1 squared, and therefore BD is root 2. Now let's figure out the other diagonal, which is AC. And AC is going to be figured out by looking at that. And that is, again, another Pythagorean relationship like this. This is 1, and then this one we have to do a little bit of work, and then we can figure out AC. AC squared will be 1 squared plus this diagonal squared. But that's pretty quick to figure out because it's the hypotenuse of that triangle, 1 and 1. So that's going to be just root 2. So it's 1 squared plus root 2 squared. So this is going to be equal to 1 plus 2, which is 3. And therefore AC is root 3. So there we go. We got the two diagonals. D1, which is BD, root 2. D2, which is AC, which is root 3, all over 2. And this is root 6 over 2. So number 21, the answer is A. Jacob uses the following procedure to write down a sequence of numbers. First, he chooses the first term to be 6. To generate each succeeding term, he flips a fair coin. If it comes up heads, he doubles the previous term if it subtracts 1. If it comes up tails, he takes half of the previous term and subtracts 1. What is the probability that the fourth term in Jacob's sequence is an integer? So we got the first term, the second term, the third term, and the fourth term. And let's see what we get for each of these. Well, the first term is 6, so that's pretty straightforward. Now, the second term. If he gets a head, he will double it and then subtract 1. So 2 times 6 minus 1 is 11. If he gets a tail, he will take half of it and subtract 1. So 6 divided by 2 is 3. Subtract 1 is 2. Okay? So now we have to do the same thing again. First, let's concentrate on the 11. If we are just looking at the 11, heads and tails will result in what? Heads, double it, subtract 1, so that's 21. Tails, take half of it and subtract 1, so 4.5. And then for this 2, if it's heads, double it and subtract 1, so that'll be 3. If it's tails, take half of it and subtract 1, that'll end up with 0. All right, now we've got 4 scenarios to deal with. And let's see what we get for each one. So the first one, 21. If you get a head, double it and subtract 1, so that's 41. If you get tail, take half of it and subtract 1, so 9.5. For 4.5, if you get heads, double it and subtract 1, so you get 8. Tails, take half of it and subtract 1, so 1.25. For this 3 now, double it and subtract 1 for heads, and you get 5. For tails, take half and subtract 1, 0.5. And then finally, for the 0, double it and subtract 1, negative 1. For tails, take half of it and subtract 1, again, negative 1. So how many of these do we have, first of all? We got 8. And how many are integers? 41, 8, 5, and the 2 negative 1s. So that's 5 out of the 8 are integers, and that's the probability. So number 22, the answer is D. Two subsets of the set A, B, C, D, and E are to be chosen so that their union is S and their intersection contains exactly 2 elements. In how many ways can this be done, assuming that the order in which the subsets are chosen does not matter? So first, let's try to understand this question. A, B, C, D, and E. This is my S. Now, I have to choose 2 subsets. Okay, so I'll just give you an example. Let's say I chose my first subset as AB and my other subset as CDE. Okay? Their union is S. What does that mean? It means that if you looked at all of the elements in the 2 subsets, they all together have to be exactly like S. Basically, that you have to use all of the elements to make those 2 subsets. So for example, if my first subset was A and B and C, my second subset must include all the other guys, which is D and E. If my first subset was A and B, my second subset can't just be D and E, because see, there's a C missing. When I create my 2 subsets, all the elements combined must be all the elements of S. Their union is S. Okay, does that part make sense? So now we get to the second part. The intersection contains only 2 elements. So for example, if my first subset, I should say, is A, B, and C, my second subset has to be B, C, D, and E. Why? Because there has to be exactly 2 elements that are common to both. And that's what they mean by intersection. So, in how many ways can you do this? All right. First and foremost, let's just choose the common 2 elements, the intersection. So let's say that intersection is AB. All right. So now I've got to choose a subset 1 and a subset 2. So my subset 1, the minimum number of elements in subset 1 is going to be 2. And that means that it's just going to be A and B. So there's nothing else. Okay? I'm going by minimum, and then we'll go up by then. S2, therefore, has to include the other guys, C, D, and E. So that means S1 has 0 in terms of its selection other than AB. So S1 basically is AB, and S2 is A, B, C, D, E. That's what S1 and S2 are. What's common? Well, what's common is AB. That is the intersection. So there you go. This is one such scenario. And we have to figure out how many of these are possible. So this one was when S2 had 2 elements in it. So 2 elements. And when S2 had 5 elements. Right? There's 5 and there's 2. And the common was AB. Now we have to figure out what other scenarios are there in terms of numbers. I did 2 and 5. Can I do anything else? How about 3 and 4, perhaps? I think that is the only other way I can do this. So 3 and 4. 3 elements in S1 and 4 in S2. So for example, AB is common to both, as always, but then I've got to put one more element in there because it's got to be 3, and I've got to put just 2 more in subset 2. So how do we do that? Well, first and foremost, what are the remaining letters, C, D, and E? So I've got to arrange C, D, and E. Well, I can do it like this, either C, D, and E, or D, C, and E, or E, C, and D. Okay? So, for the first one, I had only just one possible way of doing that, one arrangement. But for this second scenario, I have 3 possible arrangements. Okay? And if you keep fiddling around with these numbers, you'll see that this is the only way of doing it. You can't have anything else. You can't have like 2 and 2 or 2 and 1, because the fundamental rule is that all of these must be used when you create the 2 subsets. So I got 1 and 3, so that's 4. 4 different ways that this can be done. But these answer choices are all much greater than 4. Why are they greater than 4? Well, because what I calculated was only for AB. There are several other ways of creating those 2 in the middle, the 2 that are the intersection. AB is one of them, but there's others, right? There's AC, AD, AE, BC, BD, BE, CD, CE, and finally DE. This is 10. There's 10 ways of choosing that intersection, and for each of those, there's going to be 4 possible scenarios. So 10 times 4 is the total, which is 40. So 40 is the answer to number 23, which is choice B. Let k equal 2008 to the power of 2 plus 2 to the power of 2008. What is the units digit of k squared plus 2 to the power of k? Before we get started, let's just explore the powers of 2. And let's look at what is the units digit. And pretty soon, you'll be able to see a pattern. And then I will discuss how you will get the units digit for anything, any power. So 2 to the power of 1 is 2. Units digit is 2. I'll just put units digit up here. And similarly, we got 4 and 4, 8 and 8, 16, but 6 is the units digit. 32, 2, 64, 4, 128, 8, and 256, 6. So as you can see, it alternates 2, 4, 6, 8, 2, 4, 6, 8. It's a pattern. It keeps on going like that. So if I had any power, say I wanted to figure out the units digit of 2 to the power of 2008, I can get that pretty quickly with this pattern. What I always do is just look at the multiples of 4. So if the exponent is a multiple of 4, the units digit will be a 6, as you can see. Is 2008 a multiple of 4? And the answer is yes. 502, I believe. So very quickly, you can figure out that the units digit of 2 to the power of 2008 will be 6. So there you go. So what we have to do is try to figure out what this is. What is k? If we can figure out k, then we can figure out what this is. So let's concentrate on k first. K is equal to 2008 to the power of 2 plus 2 to the power of 2008. Okay? I'm going to break this up into prime factors. Let's see here. I think that's 251 times 8, all to the power of 2. And we'll just leave this guy alone probably throughout. So 251 squared plus 8 squared. But 8 is 2 to the power of 3, all squared like that. And then this is just 2 to the power 3. You combine those by multiplying, so that's going to be 2 to the power of 6 times 2 to the power, so 251 to the power of 2 plus 2 to the power of 2008. Now I'm going to factor out the 2 to the power of 6, and this gives me 251 to the power of 2 plus 2 to the power of 2002. Okay? 2 to the power of 6 is 64, and then these numbers are pretty manageable. 251 is 63001 when you square it, but this is a big number. I've got to figure out the units digit of that. So 2 to the power of 2022. This is where our table comes in. Okay, is this first and foremost a multiple of 4? Can you divide 4 into it? And the answer is no. But 2000 is a multiple of 4. It's 500. So 2000, 2 to the power of 2000, the units digit will be 6. So you just follow this pattern. 2 to the power of 2001 will be 2 in terms of the units digit, and 2 to the power of 2002 will be the next guy, 4, as the units digit. So I'm just going to write the units digit there. Okay? Now, at this point, I want you to notice that when you add 1 with 4, you get a 5. So I'm just going to write the units digit there, like that. And 4, or 64 rather, is obviously a multiple of 4. It's 4 times 16. And this multiplication leads to 320. And as you can see, the units digit there is 0. So now we turn our attention to this right here. K squared plus 2 to the power of k. Well, the units digit is all we need to worry about. If the units digit of k is 0, if you square it, that units digit will also be 0, right? 0 times 0 is 0. But what about 2 to the power of k? Well, we have to figure out what is k. Now remember, k is some big long number. It's really represented in full up here. And we just were looking at units digits. But if you look at this number right here, you'll notice something, I hope, that this number don't worry about right here. Just look at this right here. 2 to the power of 6. What is 2 to the power of 6? It is 64. And what is 64? It's 4 times 16. So that means that k is a multiple of 4. And therefore, this will have a units digit of 6. So this just becomes 0 plus 6, which is 6. And therefore, number 24, the answer is D. A round table has a radius of 4. 6 rectangular placemats are placed on the table. Each placemat has a width of 1 and length x as shown. They are positioned so that each mat has 2 corners on the edge of the table, these 2 corners being endpoints of the same side of length x. Further, the mats are positioned so that the inner corners each touch an inner corner of an adjacent mat. What is x? So a little bit of labeling, of course. I'm going to first connect all of these guys. And this looks like a 6-sided shape. 1, 2, 3, 4, 5, 6. And therefore, all of these angles inside are 60 degrees. That's 60, that's 60, and so on, all the way around. Now, what's interesting is that when you draw these lines, you'll notice that each of these lines is the same. That's the same in terms of length to that line. So that means this is isosceles. If it's isosceles, that means these 2 angles are the same. So 180 minus 60, which is 120, is going to be equal to 2x. So that means this is 60, and that's 60, like that. So these are all equilateral triangles, basically. That's 60, and so on. So that's the first part of this question. Now I'm going to draw a few very important and helpful clues. The first is from this point right here to that point right there. The next is this segment, which essentially represents x, and then I'm going to connect that right back to where I started, like that. Okay, and I think that should be sufficient. So let's label this now. This point down here I'll call R, this point up here I'll call P, and this point here I'll call Q. And this is 90 degrees because that's part of a rectangle. So a few things that we need to write out that the question actually gave us. They told us that the radius is 4. Now, the line PR that I wrote goes through the center, and therefore it represents the diameter. So PR is 8. Right? And then PQ is equivalent to our x, which is what we have to solve for in this question. So immediately in this right triangle, PQR, I know that PQ is x, and PR I actually have the numerical value of 8. So now, of course, I have to concentrate on RQ. Well, RQ, part of it we know. We know this guy right here, this little distance there. They told us that is 1. So this is 1. I'll squeeze that in there. That's 1. Now I need to figure out the distance from here to here. If I can do that, I shall be able to use Pythagoras. Well, the good news is this little guy in there we also know is 1. Okay? So I guess now we just have to figure out from there to there. And we can label those 2 points if you really want to. We can call this point and this point, we can call them S and T. So this is S, this point right here, and this point right here we can call T. Okay. Now take a look at this triangle right here, this one. That triangle you can clearly see because this is x and this is x. That triangle is isosceles. And therefore, this angle and this angle are the same. Now, this whole thing is 120, so therefore this angle is 30 and this angle is 30, like that. What I'm going to do is just look at this triangle right here. I'm going to actually draw it out here to avoid making this diagram too messy. And there you go. That's that triangle, 30, 90, and 60. And this side is x. And this is what we're going to use to figure out the distance from S to T. This side here, I don't know what it is, so I'll just call it st over 2, which is basically what it is. And now 30, 60, 90, the ratio of the sides are 1, 2, and root 3. So we can use that to figure out st. St over 2 over x is equivalent to root 3 over 2. So that means st over 2 is equal to root 3 over 2x, and therefore st is equal to root 3x. There we go. So now we've got a Pythagorean relationship with triangle PQR, and that is as follows: PQ squared plus QR squared is equal to PR squared. PQ is x. QR, okay, QR is first, we've got this distance, which is 1. Then we got from S to T, which is root 3x. And then we've got this little guy here from T to R, which is 1. And all of that squared. And then PR is just 8. So this is the equation we have to solve. So we've got x squared plus root 3x plus 2 all squared is equal to 8 squared, which is 64. So this is x squared plus 3x squared plus 4 root 3x plus 4 is equal to 64. Bring everything over on one side, collect like terms. 4x squared plus 4 root 3x minus 60 divided by 4 will get rid of a lot of 4's. And we just get left with x squared plus root 3x minus 15. And this is most likely going to need a quadratic to solve. So we got x is equal to minus root 3 plus or minus the square root of root 3 squared minus 4 times 1 times negative 15 all over 2a. And this looks like minus root 3 plus or minus 3 plus 60, so root 63 all over 2. Now x is a distance, so it's most likely minus root 3 plus root 63 over 2. And I think we can simplify the root 63. It's 9 times 7, so 3 root 7 all over 2. So there you go. Minus root 3 plus 3 root 7 over 2. Minus root 3 plus 3 root 7 over 2. And that is choice C for number 25.